Hello everyone, and next video lecture about center of mass from system of particle lesson. This is major topic in this lesson. What is the center of mass and how it is very important in our lesson. Let's go to the topic. Center of mass, in shortcut we can write it as COM, center of mass. So center of mass means if any particle of the system, point mass of the system, the entire mass of the system can be located at one point, that is called center of mass. So I am going to explain taking of one example. This is notebook. So this is carries all the particles having number of particles in the system. The sum of particles made as a notebook. So somewhere any one point, the total center of mass can be located at one point. The entire mass of the system. See, when I place the one single finger on notebook, the book can be held like this. Means at the point of finger, the whole mass of the body locating at one point. That is called center of mass. And you can take number of examples. For suppose have a duster. This duster has some particular shape. So this particular shape we can assume that any center middle of the point the duster can hold. Somewhere it is not possible, right? So this is experimentally. Somewhere it is not possible, it is falling down. Because of that, wherever the center of mass can be held. See, the entire mass of this system can be held at one point, that is called center of mass. This is means, if I write the definition for center of mass, the entire mass of the system can be supposed to be located at a single point. Is called center of mass. The entire mass, if we take any system or any body, that body is supposed to be located, entire mass of the system supposed to be located single point. That point is called center of mass. The major important topic is center of mass. We have a number of examples. Just now we took that duster, right? It has some particular shape, that is we can call rectangular shape. So this is for suppose duster. Where it is located now? This is exactly at the center. It is called center of mass. You can see is center of mass. Wherever the entire mass can be located in duster. If you take disco, for suppose I am taking. This is sum of disco. Okay, where the possible center disc or cylinder? Definitely it is at center. Okay, this is center. For suppose this is, let's say, disc or cylinder, and this is rectangular plate. Like this, we have a number of examples for center of mass. Okay, center of mass, we have one more very important example, which is, remember one point about center of mass. The mass is not mandatory to locate at the center. Okay, for suppose I am taking one ring. Okay, for suppose I am taking here one ring. This is ring. Ring cannot have mass at the middle of the body, right? This system cannot have mass of the particle in the middle of the body. But if you observe the ring, where the entire mass can be located here, which means definitely it must be at center. But here it is a mass, isn't it? No, there is no mass. There is no mass means there is no system, there is no particles. But we have center of mass locating at center of frame. Like this we have a number of examples. For suppose you can take triangle sheet where the center of mass is located. This is also be at the center. Okay, and one more example I am explaining that horseshoe, we can call it is horseshoe. This is one of the shape of the body. Like this body, where the center of mass is locating, that body center is always locating at the center. This is about condition. If you have a doubt, you can take this kind of body. Wherever the entire system can be held by choosing a single point or by using a single finger, that body we can call, that point we can call center of mass. And center of mass never be constant. The center of mass always changes the distribution of masses. If the mass is changing, always center of mass also changes. That is center of mass. This is one of the examples. If you take the disc, for suppose I am taking disc. This is one of the disc. Let's say disc. This is one of the complete hollow sphere. Let's say hollow sphere. Hollow sphere. Where center of mass is locating? Definitely it is at middle of the point. This is center of mass. Okay. These all the part system of the bodies are always locating center of mass where the entire mass is locating. But one more point is center of mass is not mandated to locate at center of mass. Either be located or not be located. Okay, this is very important about center of mass. And what about equation? We need some equation to derive the center of mass or solving the problem for us. We have to develop an equation for center of mass, which is for two coordinate system. I am taking first one case is for two coordinate system. Two coordinate systems, which means xy plane or something whatever. Okay, for suppose just I am taking for one coordinate system. For this case, this is one of the axis. Let's say this is x axis and this is y axis. First of all, I am explaining one coordinate system what it is, and after that we will. Okay, if any point mass is, this is let's say origin, and I am taking here x1 point and here x2 point. Sorry, masses I am taking m1 and m2. Two more point masses are having on x-axis. So generally we know if two masses are having like means, let's assume the center C is the center of mass of the body. Okay. For suppose from the distance is from M1 to C distance. Let's take R1. Okay, R1 distance. And similarly, here to here, the distance between C to M2, I am taking R2 distance. The position distance of masses, point masses. And if you observe from origin, I am taking for this case, it has x1 distance. Okay, and it is the center. Now we are creating it is the center. We are assuming it is a center, which means from origin point to here, this is xcm. Xcm means the center of mass distance. Okay, from C point to O point. And similarly, what about M2 position? This is actually x2 distance. Let us assume x2 distance of M2 mass from origin distance. So let's prove what is the center of mass equation. So remember one point, always the center of mass of the body is inversely proportional to the position vector or distance, which means in terms of when we write the equation, the position of center of mass is inversely proportional to the mass. Which means if mass is increasing, the center of mass or the position of the center of mass also increases. This is R is inversely proportional to the mass. Okay. By if you apply the two equations, it is m1 r1 is equals to m2 r2. So apply this one. For suppose for these two systems I am applying. For these two systems I am applying r1 is equal to 1 by m1. And similarly, what about second particle? Why it is not? That is why m2 by r2. Just I am applying for two particles. That is reciprocally you can write it cross multiplication. R1 m1 is equals to R2 m2. Okay, R2 m2. Now we need to derive what is the xcm distance exactly locating from the origin to center. That distance we need to derive. So from this case, have to prove basing on these equations. Okay, let's take R1 distance from here. R1 distance. What is the R1 distance? Which is that x1 R1 is equals to, what about R1 distance here? Nothing but xcm minus x1. xcm minus x1. Okay, what is the R1 distance? Means we need this distance, nothing but we have to subtract this one minus this one, and we will get it this distance because we don't know R1 distance. And similarly, R2 distance. What about R2 distance? We need this distance, nothing but x2 is a larger value, x2 minus xc. x2 minus xc. We got R1 R2 values. Substitute in above equation 1. If you substitute value, then we will get the resultant value from equation 1. From equation 1, R1 means I am writing m1 first. R1 means xcm minus x1, and R2 means is equal to m2 of R2 means x2 minus xcm. x2 minus xcm. Just simplify it, we will get the value, that is m1 xcm minus m1 x1 is equal to m2 x2 minus m2 xc. Okay, so continuation of this simplification, we need xcm means take this equation m1 plus m2 of xcm, because minus will come, there is a plus, and is equal to, if minus will go that side, m1 x1 plus m2 x2, this is the value, effective value. And what is the xcm value? The center of position mass of the body is m1 x1 plus m2 x2 by the center of go that place m1 plus m2. This is our center of mass of the particle. This is our value. And if you apply this same equation, if you apply that equation for n particles, we are taking only two particles, that is why this equation is in terms of 2, x1, x2. If you take 3 particles, 4 particles, 5 particles, because for the example just having one number of particles. Similarly, like the particles having number of particles. If that particle have for n particles, the center of mass of the equation value xcm is equal to, tell me, m1 x1 plus m2 x2 plus and so on. Number of particles we are considering, that is mn xn. Okay, by number of masses also be summing the sum of m1 plus m2 plus and so on plus mn. This is about xcm, center of mass of the body, for n particles value. And similarly for y coordinate system also, this is only x coordinate, we are taking x axis, even it has y axis also. For y coordinate system, y coordinate system. What about position of center of mass of the value? Here it is YCM. For x value, x2 is equals to same formula. Instead of x1, we can write it y1. y1 plus m2 y2 plus and so on plus mn yn by m1 plus m2 plus and so on plus m2. Okay, this is about two coordinate system, and if you take the three coordinate system, we can add it z axis also. For the z axis, zcm, instead of y1 we can write it m1 z1 plus m2 z2 and so on, m2 z by m1 plus m2 plus m2. For simplifying the equation, if you write a small equation, it look like a very figure, right? For writing small equation of center of mass equation in terms of xcm is equals to, I am using one word, that is summation. Okay, summation of I is equal to 1 to n m1 mi xi by, okay, summation is all the number of m1 x1 plus m2 x2 all can come includes, and here summation of I is equal to 1 to n m I, or you can write it capital M, that is the entire mass of the body. This is the entire mass of the body. You can write it directly capital M also. Okay, for YCM summation of I is equal to 1 to n mi yi by summation of I is equal to 1 to n m. This is about y particles and y coordinate system, x coordinate system. Okay, we are taking two coordinate system x y above. If you take three coordinate system, we can develop x y z also. Okay, now this is about center of mass and center of mass equation, how it is depends on center of mass. If you take the complete coordinate system, that coordinate system gives as x y z. Okay, very important topic, for it plays a major role in system of particle lesson. Okay, thank you.